Alright, here's the last video of this sequence. Just to let you know, we are going to solve this one right here. So we did this one already, okay? So we just did this video. Now, how long is it in the air? We're going to solve this, but this too, both. And the reason being is to figure out how far it's going to go. So remember, this thing is shot here at 20 meters per second at 30-degree angle, and it's going to go like this, and it's going to go a certain height, right? We already figured that out, like this height right here. We figured that out already on the last video. And then it's going to land right here. And we're the last question, this third one right here, how far is it going to go? It wants to know this delta x, like this change in position, how far does it go? And pretty much to find that, it's pretty easy. We just need this, how fast is it going this direction, right? The Vx, which is the cosine. And then we need to know how long is it going to be going that fast. So it's going to be going this fast the whole time, like that, the whole time. But for how much time? So we need to know how much time is in the air. So the first thing we're going to do is we're going to figure out the time in the y direction. And look at all the stuff we know. We know that the starting speed from the last problem, the starting speed is Vy, which is equal to sine of 30 degrees, whatever the angle is, sine of the angle, times the main speed, 20. So the starting speed is 10 meters per second, like we found out the last time, because sine of 30 degrees is 0.5 in the calculator, and then times it by the main speed 20, and it turns out that in the y direction it's heading upwards at 10 meters per second. Gravity will try to pull it down at this speed right here, 9.8 meters per second squared, negatively. Now the final speed is, well, we want to know the total time all the way to this point right here, right when it crashes into the ground. Well, we're talking the y direction here. In the y direction, how fast is this thing going right before it hits the ground? We know it's heading downward, right? Because it heads upward at 10, and then it stops right here. The v here is 0. We're talking y speeds though right now, okay? Forget the x right now, because remember, we're in the y. So it heads up at 10 meters per second, slows down until it stops. Then gravity starts sucking it back downward, going faster and faster and faster, until right before it hits the ground, it's going to be going negative 10 meters per second. Remember, that was one of the rules on my rule sheet for gravity problems, is that the speed that it heads up is the same speed that it heads down, as long as it's coming back to the same height. And of course, in this class, that's what we're going to assume. And then, of course, we're looking for time, like how much time is it in the air. I think for that we're going to use this equation right here. It's delta x. Wait, no, it's not delta x. We have a couple equations. Acceleration is equal to final velocity minus initial velocity. The original speed, divided by time. That's the one we're going to use, that original equation right here. And that should do it, because that's the only one that has these four things in it. I kind of drew a blank there for a second. So final speed is what? Negative 10? Minus the starting speed of positive 10, so we just say negative 10. So negative 10, that's the final speed. Take away the 10, right? Because it's just a positive 10, there's no negative there. So it's negative 10 minus 10, divided by t, we don't know what t is. And then a is negative 9.8. And then remember the rule, I told you there's an algebra rule that says you can swap everything on the left side here with everything on the bottom. So let's just do that. And t is equal to negative 10 take away 10 divided by negative 9.8. And let's see if I can do this here. There we go. And what is this? Negative 10 take away more 10, another 10, is going to be negative 20, divided by negative 9.8 is equal to t. So let's do a quick calculation here. 20, it's 20 divided by 9.8. And we got it, it's 20 divided by 9.8. There we go. And 2.04. So, and notice it's a negative divided by a negative, so we're going to get a positive, which is good. Time should always be positive. If you got a negative time, you did something wrong. So the time is 2.04. That, if I'm not going to ask you any questions like that in the final or anything like that, like how much time is this thing in the air, you're going to have to figure that out to know this one. So I'm going to make you look for this. And the first step you have to do is this right here, all this work. Pretty much set it up in the y direction to figure out how long it's going to be in the air. So pretty much that's how long it's going to be in the air. If you throw something up at 10 meters per second, it's going to slow down and it's going to come back down looking at the y direction only, and it's going to be heading back at the same speed you threw it up, just negative though, of course. So set that up right here. We're looking for time. We're looking for time. And where's my pen here? And you know the final speed is always the opposite, negative, of the starting speed. And then of course a is always negative 9.8. And that's it. And then use this equation, and that will give you the time that this thing is in the air. Now the x directional stuff, where we're going to get our answer for this right here. So the answer to this, how long is it in the air? It's 2.04 seconds. We know this answer right here, okay? This answer is 2.04 seconds. How far will it go? Well, first we need to know how fast is it heading to the right. And so if we look at that, this is going 20 meters per second that way, but it's at a 30-degree angle. So how fast is it heading this way is what we're looking for, the Vx, the speed in the x direction. And that's simply the velocity we're looking for here is it going to be equal to the cosine of 20 degrees. Somewhat opposite. Remember this one was the sine, right? Right here, we had to use the sine. So here we go. So it's a cosine of 20 degrees times 20, the main speed. Oh, did I put 20 as 30? Sorry. The cosine of 30 degrees times 20. Sorry if I confused anybody there. So now let's get our sine. There's no sine here. So I'm going to go over here, not a standard calculator. Let's go to a scientific one. There we go. And I'm going to take, I think on this calculator, do I put the number first? I forgot. Where's sine? Trigonometric sine. Yeah, there we go. Okay, so that did work. It's 0.5. So now let's go 30, and let's do the cosine. It's this number here, and we're going to times it by that main speed of 20. And I get 17. It should always be less, by the way. Both these components, I don't know if I ever mentioned that, but this component here, the speed in the y direction and the speed in the x, will always be less than this. It can never be more. This is the most speed you're ever going to get right here, and these are just partials of that. So our answer is, what was it again? 17.3. So 17.3 meters per second is the velocity. That's how fast it's moving. It's going to do that for how much time? 2.04 seconds before the y speed just crashes it into the ground, right? Remember, y is going to kind of just, I'm using my camera finally, y is just going to suck it straight down into the ground and slam it into the ground. The x is just going to kind of keep going and going and going and going, and then y is going to go black and slam it into the ground and not let it go anymore. So this is a simple problem. Remember, in the x direction, there's no acceleration. So velocity is just how far you go divided by time. And we're looking for this. So let's plug everything in. Velocity is 17.3. I put 17. It's 17.3, I think, meters per second is equal to delta x. We don't know that. Divided by the time, 2.04 seconds. Just times 2.04 on both sides. Times 2.04 on both sides. That gets it rid of over here. And that puts delta x by itself. So it's pretty much, you're going 17.3 meters per second every second for this amount of seconds. And then it'll tell you how far you go. So let's just take this number, the 17.3, and times that by the 2.04 seconds. And we get about 35.3 around there. 35.3 meters. And that is our final answer to our question, which was how far will it go? And the answer is 35.3. So that's the answer, 35.3. Make sure you try to solve that yourself. So this one has a couple of steps. Remember, if you're trying to figure out how far it goes, which is what you're going to have to do in the practice problems, how far is this thing going to go? Like this? Like how far? This question right here? First thing you got to do is figure out how long is it in the air. So we're going to have to do this and figure out how long it's in the air. So make sure you rewind the video and figure out how long you're in the air. That's important. Then you have to figure out how fast you're heading to the right using cosine right here. So the cosine of the angle times the main speed. Here's the main speed, right? The main component of the speed. Then you times it by the cosine of that angle. And that'll give you how fast you're heading to the right. You already know how much time you're heading because we calculated that over here in the y direction. And then pretty much you're really just multiplying these two together, these two numbers, just multiply them together. And that'll give you the answer. And that's it, okay? So make sure you write those notes down, do a little practice problems until you get them right. And And if you have any problems, come see me and talk to me, okay?